Welcome to Object-Oriented Programming course. From today we are starting the second module. In second module, that is subdivided into three subsections. First subsection is all about the primitive data types, operators, control statements and all. In the second subsection, you will learn about how the object-oriented concepts are implemented in Java. In third subsection is all about inheritance and related things. So in today's class, we will learn about primitive data types, then literals, type conversion, and we will start what is we will introduce the concept of variables. Let us start with data type. Data type defines the type of values that a variable can hold. See here, you can see this diagram. So in this image, you can see a bucket written as champagne bucket. So that the type of the bucket is set as champagne bucket. That means within this bucket you can keep champagne bottles. So in the same way, data types type signifies what type of data you can store in a variable. Java is statically typed, which means all the variables must be first declared before they can be used. So in some languages you can use variables without declaring it in the beginning. But in Java that is not allowed. You have to declare a variable explicitly stating its data type in advance. Okay, that's why we call Java statically typed. Then Java is strongly typed. Every variables and expressions in Java are having a strictly defined data type. Whenever there is any mismatch in your expressions in terms of size, then the Java will treat that as errors, and such errors must be corrected by the programmer. So we have to remember two things. Java is statically typed. That means you have to declare a variable before using it. Then Java is strongly typed. That implies types should be matching. Type should be compatible in all the expressions. Whenever there is any mismatch, that will create error during compile time. Okay, here you can see an example of a variable declaration. Char flag equal to a. So this is nothing but you are declaring a variable named flag and its data type is char. Char is the keyword used to represent a character data type. And we are doing the initialization also. You are storing a value character a. So this particular keyword char represents the data type, then the variable name, initialization value. So that's all about the concept of data type. Now let's see the overview of data types in Java programming language. In Java, we can classify the data types into two broad categories. One is primitive data types, that includes Boolean, character, integer, floating point data types. Okay. Then second category is non-primitive data types, that includes strings, arrays, objects, etc. Let's see the details of primitive data type. A primitive data type is predefined by the language and the type name is a keyword. So type name will be a keyword. In Java, there are 8 primitive data types. They are byte, short, int, long, character, float, double, and Boolean. I think in this, Boolean will be new to you. In C programming language, Boolean was not there. Let's start with the integers. Okay, to store the integer values, you have byte, short, int, and long, which are for word valued signed numbers. So everything will be signed numbers that you have to remember. And to store the fraction numbers with the fractional values, you have floating point data types. They are float and double. So these are to represent numbers with fractional precision. Then to store the characters, means the alphabets of any language, which represents the symbols in a character set. You have a data type called char, char. Now there is a separate data type Boolean that represents true or false values. So thus we have 8 primitive data types in Java programming language. Let us start with integer. So to store the integer, that means all numbers, you have 4 different data types. Just look at this image. So this is the essential difference between these data types. The capacity, the size varies between these types. The integer data types are used to store whole numbers like 2, 3, minus 5 or whatever. Means this is to store the signed numbers, signed whole numbers. There are 4 types to handle signed whole numbers. In C++, size of int is dependent upon the platform. So in terms of programming language, what is the size of an integer? You cannot give a concrete answer because it is dependent upon the execution environment. But in the case of Java, language is defining the size of each data types. Okay, for byte, it is one byte. For short, it is 2 bytes. For int, it is 4 bytes. And for long, it is using 8 bytes. So, irrespective of the platform, in Java, all the data types will be having predefined fixed size. Okay, that is a very important feature in Java. It is not like C or C++ where it was dependent upon the execution environment. In Java, size is defined by the language. Let us learn about the data types to store the floating point values. Floating point numbers are nothing but the data types to store the fractional numbers with fractional precision. There are 2 types, float and double. Java supports IEEE 754 implementation of floating point numbers, and the data type float is to represent single precision floating point number, and it uses 32 bits. And double is to store the double precision floating point numbers, and it uses 64 bits. Okay, here you can see that a representation means floating point representation used in Java. Now let us see some examples. Here float f equal to, I am initializing with one value. So here f is the float is the data type, f is the variable name, I am initializing that with one value. And if you try to compile this particular line of code, you will get compiler error. Any idea why you are, see, means in terms of syntax, actually you cannot figure out any major issues. Semicolon is there, but it will produce error because a float is single precision, and if this particular literal cannot be stored in a float value. So this is actually a, by default, if you are not mentioning any types, any characters at the end, it is treated as by default this is a double constant value. So this literally is nothing but double value. So you cannot store a double in a floating point value. But at the end, if you suffix an f, then this compiler error will disappear. And if you try to print this value, see, I stored like this, no compiler, because I suffixed an f symbol to tell the compiler that okay, my constant is of type float, so it will compile. And if I try to print, in the output I can get only 6 values after the decimal point. That means your float is having single precision, so it can support only 6 numbers after the decimal point. Only that much is the accuracy of a float. And now let us consider the case. Instead of type float, here I am using double D. I am initializing with the same value. You won't get any compiler error because the data, this is double and the data type is also double. There is no mismatch, so you won't get any error. And if you try to print, you will get the same, means after decimal point you will get all the numbers. Double is having double precision, so it can support up to 15 positions after the decimal point. So in our case you don't have 15 position, but double precision can support up to 15 positions after the decimal point. A single float means a single precision, that means a float data type can support only 6 places, whereas double can support 15 positions after the decimal point. So this you have to remember. And by default, if you represent a floating point, means a fractional value like this, compiler will treat this as of type float, of type double. So to indicate that its type is float, you have to suffix an f at the end. Next primitive data type is character. In Java, the character data type used to store the characters in any language. Okay, means any means natural language. Java uses Unicode to represent characters. At the time of Java's creation, Unicode required 16 bits. Thus, Java character char data type is of length 16 bits. See, I said it is to store the characters or the symbols of natural languages. See, in world there are so many languages. It is not just English. So if you have to store the characters of all the languages, you cannot see in C language size of the character was 1 byte, but in Java it is 2 byte because it has to support all the languages across the globe. So that is why it is following Unicode. Unicode convention is there. So in Java it is supporting Unicode characters. At that time maximum size of Unicode character was 16 bits. Now, so because of that reason, in Java characters are of length 16 bits. Here you can see an example. Char letter A. See, it is given in single quotes. That means it is a character constant. Letter is the variable name, char is the data type. And if you see this, each character is occupying 2 bytes. This is an array, means a character array with 3 positions. That means it will have 6 bytes because to represent one character, it requires 2 bytes. It is not like C. In C, one character was occupying 1 byte, but in Java, one character will occupy 2 bytes. And if you are storing our normal ABCD or something like that, ASCII values, in that case also, it will occupy 2 bytes. First byte will be 0. See, to store the A, means English alphabet A, first byte will be 0, second byte will be 61. To store B, first byte will be 0, second byte will be 62, and so on. So remember the point. In Java, character data type is having length 2 bytes. It is 2 bytes, not 1 byte. Okay, because it is supporting Unicode character set. Next data type is Boolean. This is something new compared to the C language. Boolean data type has only 2 possible values, either true or false. Use this data type for simple flags that are true or false conditions. So in your program, wherever you need to store some true or false condition, you can use this Boolean data type. This data type represents 1 bit of information, but its size is in something that is precisely defined. Initially I said for all the data type, Java language has defined the size. But in the case of Boolean, language is not explicitly telling the size, because for the Boolean value you need only 1 bit of information. Means you are actually storing 1 bit of information, true or false. But to implement that, you can use either 1 byte. That is actually how the virtual machine is implemented. The size of the Boolean data type is virtual machine dependent, usually 1 byte. Value of the Boolean are not converted implicitly or explicitly to any other type. That means you cannot convert Boolean to 1 or 0. Boolean is treated as a separate value, separate type. This is the type returned by all the relational operators, like less than, greater than. All these relational operators will return true or false conditionally, so that data type will be Boolean. Example, okay, here you can see an example. You have created a Boolean flag. Data type is Boolean, variable name is flag. So in this flag, I can store true. I am not storing 0 or 1. I have to store true or false. So when I print, I will get the, means if you try to print this value flag, it will be printed like true. Okay. In Java programming language, in the beginning we said Java is all about classes and objects. But these primitive data types are not treated as objects or classes. They are different. But there are many cases where you have to pass corresponding objects corresponding to these data types. So for such purpose, there is something called wrapper class. Primitive data types are not objects. Wrapper class provides a way to use primitive data types. Means for integer, boolean, for all these types, if you need object, in that case you have to go for the corresponding primitive, means wrapper class for that corresponding primitive data type. Primitive wrapper classes are used to create objects that need to represent primitive data types. To represent to have the object representation of a byte value, you have to use the wrapper class byte. To have the object representation of a boolean value, you have to use the class boolean. To have the integer, means object representation of an integer, you need to use the wrapper class integer. In the same way, these are the wrapper classes. So whenever you need to have the object representation of the primitive data types, you have to use the corresponding wrapper classes. So you will understand the need for these wrapper classes when you learn the collection framework and all. We are just introducing that concept right now. Next part is literal. What is literal? A literal is nothing but the constant. Primitive data types are special data types built into the language. They are not objects created from a class. A literal is the source code representation of a fixed value. I said literal is a constant. Don't confuse with any variable. A literal is the source code representation of a fixed value. Means I want to represent digit 5. So in my source code I am representing that as 5. That is nothing but a literal. I want to represent a string hello in my source code. So that source code representation of hello within double quotes is nothing but a literal. So literal do not change during the execution. Literals are represented directly in your source code without requiring any computation. You are directly mentioning that value. As shown below, it is possible to assign a literal to a variable of a primitive type. Okay, to a Boolean value, result is a Boolean typed value. To that you can store either true or false. These only two literals are possible to store into a Boolean value. To a character literal, see I am creating a character variable capital C. To that I can see any character value, means that should be within the single quotes. I can store so this particular C is a literal. This was a literal. Now to byte value I can store 100. That is allowed because 100 will fit in 8 bits. So this 100 is nothing but a literal. To a short value I can store 10,000. Fine, that will fit in the size, and this is nothing but a literal. So a literal is nothing but the source code representation of a fixed value. So here you look at this table. These are the integer literals. It can be signed or unsigned. Now floating point literals 3.14. All these are floating point literals. String literals, things will be within the double quotes. See, don't get confused that okay, this is a numeric value for if you see the content, it is numeric value, but that is within double quotes, so it will be treated as a string only. So these are all string literal, and the characters placed within single quote, those are character literals. And for Boolean we have only two supported literals, that is true or false. No double quotes, single quotes, nothing like that, just true or false. Integer literals. Integer literals are used to represent decimal, binary or hexadecimal value. Integer literals are used to initialize variables of integer data type: byte, short, int, long. Integer literals ends with L, means small letter or capital letter L, to indicate the type long. In Java, a binary literal starts with 0b and the hexadecimal literal starts with 0x. And the rest every integer literal is decimal literal. Okay, means if you want to specify that the radix is different, not 10, in that case you can go for 0x or 0b. Okay, here you can see one example. This is one integer literal 18 decimal notation. Okay, 0b prefix means it is binary representation. Okay, here I am representing a binary literal. 0x prefix indicates that it is a hexadecimal notation. Now I want to tell that okay, this particular literal, this number is of type long. It should be stored in a data type having means in a variable having data type long. So I have to add one L at the end. It can be small letter or capital letter, but I have to uh, add one L at the end. Floating point literals. A floating point literal is of type float if it ends with the letter F, whether it is small or capital. It is not case sensitive. If you are adding an F at the end of the floating point value, its type will be float. Otherwise, it will be treated as double. Otherwise, its type is double, and it can optionally end with D. It can be capital or lowercase. Even if you are not giving any D at the end, default is double only. So if you want to represent your literal value of type float, in that case you have to add one F at the end. The floating point types float and double can also be expressed using the scientific notation. Here we can see the different notations. Double, I am representing 123.4 as a double value. I need not prefix D at the end because default is double only. This is the scientific notation. Effect is same. I am storing that as a scientific number. Same data type is also same. If I have to store this particular value as a float literal, I have to add one F at the end. Characters and string literals. Literals of type character and string may contain any Unicode, that means UTF-16 characters. The string literals are represented as a sequence of characters surrounded by double quotes. Okay, for character we use single quote, for string we use double quote. Character literal is represented as a single character surrounded by single quote. Java also allows the use of escape sequence like C language in string and character literals. Okay, /b backspace /t tab. So this is same as that of the escape sequence what you learned in C programming language. So that list is given. Let us see some example. Here A is a character literal because it is within the single quote. Okay, this is actually /n within the quotes. Within single quotes, if I give a /n, that is indicating a new line. Okay, if I give something in double quotes, that is nothing but a string literal. Underscores characters in numeric literals. This is something new to you. In Java SE7 and later, any number of underscore characters can appear anywhere between digits in a numerical literal. This feature enables you, for example, to separate group of digits in numeric literals, which can improve the readability of your code. Just imagine you have to store a credit card number into your code. So usually a credit card number will be having 4 parts. Each part will be having 4 digits. So if there is a provision to separate each part, then we can easily check such numbers. So readability will increase. For that purpose only, these underscore characters are used. They can be added only between digits. That point you have to remember. Here we have some examples. See, credit card number, I am separating each part with an underscore. And at the end, I am adding one L to indicate that this is a long value. Okay, so even for Aadhaar number, whatever things you want to represent like this, you can use this underscore just to enhance the readability. 3.14 underscore. In this way, this is allowed. These are all allowed combinations. Okay, because the underscore is placed between the digits. Okay, you can add this underscore in hexadecimal, binary. In all the cases, you can add underscore between the digits to enhance the readability. But there are some rules. You can place the underscore only between digits. You cannot place the underscore between okay, in the following places: at the beginning or end of a number, that is not allowed; adjacent to a decimal point, that is also not allowed; prior to f or suffix. See, a rule is very simple. Both sides should be a digit. Okay, let us see one example. 3 underscore, this is not allowed because one side is one side is digit but the other side is a decimal point, so it is not allowed. Here also it is not allowed because it is the at the beginning one side is digit, the other side is x, not allowed. One side is x, the other side is digit, not allowed. See this example here also, here it is okay because it is between the digits. And just check this, x3 equal to 5 couple of underscore 2, that is fine, no issue. Okay, that is allowed. You can have, you can insert multiple underscore, that will not create any problem. So this you have to remember, this particular change is something new in Java. Now we have already stated many in many examples about variables. Here we are formally telling what is a variable. A variable is the basic unit of storage in any programming language. Here we are telling about Java. A variable is defined by the combination of an identifier or the name, a type, and an optional initializer. See this, int count equal to 100. So int is the data type, this is the identifier or the variable name, and this is the initialization part. In addition, all the variables have a scope which defines their visibility, and lifetime which indicates how long the variables stay alive in memory. There are two associated concepts, scope and lifetime. Scope indicates the area where it is visible. Lifetime indicates how long it is active in memory, how long the variable stays alive in memory. Here are several examples of variable declaration of various types. Note that some includes an initialization. Let us see one example. Int ABC. You are declaring 3 integer variables, means all the 3 are having int data type, and here you are declaring d equal to 3. Okay, ef declaring, okay, so you are initializing also. In this case you are z is a byte, data type is byte, and you are initializing that with 22. So here you are initializing a string with name. So variable is nothing but a container where you can store the value. So that storing process is nothing but initialization. So here I am creating a my variable. So this is my variable, that its type is int, so I can store integer in this variable, and in initialization I am storing one value into that variable. Variable naming rule. Variable names are case sensitive. That means uppercase name is different from lowercase name. Variable names can be any legal identifier. The only allowed characters for identifiers are all alphanumeric characters, then underscore and dollar symbol. Only two additional symbols are allowed apart from the alphabet and digit. Okay, geek @ is not a valid Java identifier because @ is not a valid character for identifier. Whereas geek $ is valid because $ and underscore are allowed in variable names. Identifier should not start with digit. It should start with alphabet, underscore, or dollar. Reserved words cannot be used as an identifier because keywords are already having some predefined meaning, so you cannot change it. Int while equal to 20, it's not allowed because while is already having a different meaning, and you cannot use that as another variable. While is a reserved word. In previous slide, we mentioned the rules. Now I am telling the convention. Okay, convention is something which is recommended. If the name you choose consists of only one word, spell that word in lowercase letters. So if your variable name is just one word, spell the entire word, means keep that entire word in lowercase letters. Okay, if it consists of more than one word, capitalize the first letter of each subsequent word. First word, keep it as lowercase letters. For the second word onwards, capitalize the first letter. This style is known as camel casing. First word, begin from the second word onwards, beginning first letter will be capital. So this C is in camel case. C is capital. Let us see some example. Gear ratio. Gear represented in small letter in ratio, first letter is capitalized, current year. So in all these cases, you are recommended to use camel case naming convention. In Java, that is recommended. If your variable stores a constant, such as static or final, in that case, you have to use capital letters, and when there are multiple words, use underscore to separate the multiple words. Num underscore gears. Everything is represented in capital letters. The convention changes slightly. Capitalize every letters and separating subsequent words with the use of underscore characters. So this is the naming convention recommended in Java. I mentioned along with variable there are two concepts, scope and lifetime. Let us try to understand it and understand that in detail. Here I have a class, public class scope2. Within that I have main method. I have created a block using curly braces. I am creating one block. Within that I declared one variable r. And if I try to print this variable r outside this block, I will get error because the scope of this variable is limited to the block where it is declared. That means this particular variable scope is limited to this block only. After that, see, my print statement is after the block, means it is in the outer block. So I cannot access this particular R because it is outside the scope. That is the concept of scope. Now lifetime. Okay, here let us consider this example. I have main method. Not main method. I have a min method. Min function is there. I have created one double. M is there. Okay, and here I am doing some computation and returning lifetime of the parameter a and b. So the variable a and b, the argument a and b are valid in memory only during this much period of execution. Once my execution completes this part, once my execution completes this function and returns from this function, these two variables a and b are not valid in memory. They are deleted from the memory. Or their lifetime ends. So this is all about lifetime. Lifetime indicates the duration until which the variables are valid in memory. So after the lifetime they are not valid because their storage is either released or their storage is not valid anymore. That is nothing but the lifetime. Scope indicates whether they are accessible. So beyond the block it is not accessible. Let us see the types of variables. In Java, there are three types of variables. First one is instance variable. They are nothing but the member variables declared in a class. Static or class variables. They are the member variables declared with the static keyword prefix. And local variable. These are the variables declared within the constructors or with methods. Here you have an example. Class A, int data. This is nothing but an instance variable. This m is nothing but a static variable because it is having static prefix. They are known as class variable or static variable. And this int n, this is a local variable because that is declared within a method. If it is declared within a method or within a constructor, it is local variable. So static variable is not part of the class, object. It is part of the, see, at the time of UML we learned two things, classifier scope and instance scope. Instance variable are having instance scope. That means that will be part of every object of class A. Classifier scope means that will be part of the class, not that will not be part of any object. So we will, okay, so there are three types of variables in Java: instance, class, local. Type conversion. Okay, when a data type is converted into another data type, that is called type conversion. When a variable is converted into a different data type, the compiler basically treats the variable as of new data type. The type of type conversion, okay, there are two types of type conversion in Java: implicit conversion and explicit conversion. So here I am focusing on the primitive data types. Even for object there is upcasting and downcasting that I will explain at the end. Okay, first let us try to understand what is implicit conversion. Implicit conversion or automatic conversion, compiler will automatically change one type of data into another type without data loss. That means if there is a need, compiler will automatically change a byte into short or short into int into long, means it will do the widening. It will convert a data type to its wider version or its a larger version. Okay, so this will happen silently. That's why it is known as implicit. Implicit or automatic conversion can happen if both types are compatible and the target type is larger than source type. If the target type is larger, then it will that widening will happen automatically. If you assign an integer value into a floating point value, the compiler will insert the code to convert the integer into a float. So byte will be converted to short, short will be converted to int. Like that, this widening operation will happen. Explicit conversion. There may be a situation when we want to convert a value having larger type to a small type. So here you have to be very careful. In the previous case, we were storing a value of small type into a target type which is bigger. That means there is no data loss. But now we are talking about the case where there can be data loss. There may be a situation when we want to convert a value having larger type into a small type. Obviously, data loss is possible because the target is having less space compared to the source. In this case, casting needs to be performed explicitly. So, for the narrowing operation, compiler won't do it silently. Compiler will ensure that programmer has taken care about this. So, compiler will force you to do the explicit type conversion. Otherwise, it will be creating error. Okay, if you want to store a double value into a float value, you have to explicitly cast the value into float. So compiler is ensuring that okay, programmer is aware of this data loss. Programmer is means doing this in the intended manner. In this case, casting needs to be performed explicitly. Explicit casting allows you to make this type of conversion explicit, or it force it when it won't normally happen. Syntax is like, in bracket you have to give the type to which the expression has to be converted, then the expression or the variable name. To perform typecasting, put the desired type including the modifiers inside the parenthesis to the left of the variable or the constant you want to cast. So here you have to means along with the modifier you have to keep. Okay, let us see one example. Double d equal to 10. So I want to store this d into an int variable I. I know I'm storing 10 only. So technically there is no data loss because as a programmer I know I have stored 10 only in this value d, and the integer value can also store the same value. But from compiler's viewpoint, you are storing a value which is already occupying 8 bytes into a variable which is having only 4 bytes. So compiler will force you to do the explicit typecasting. If I did not add this typecast operator, compiler will give error because from the compiler's viewpoint, I am losing some data. So as a programmer, I have to add this line I equal to cast operator then d. I am casting the double value to integer value then storing it to the integer value. Here another example. In this case, int number float value. Okay, my requirement is that actually I am not worried about the fractional values. I want to store only the whole numbers. As a programmer I know that, but compiler does not know that. So if that is okay for me, I can store this f value to an integer value. When I store, I will lose the fractional value, that is the data loss, but that, as a programmer I'm okay with that. So in that case, I can tell the compiler, convert my floating point value into an integer and store it into number. So that's all about the explicit conversion. Explicit conversion programmer has to do. It is the narrowing operation. Your source data type is bigger and the destination type is smaller. In that case, you have to do the explicit conversion, otherwise compiler will give. Now there is something like upcasting and downcasting. Till now, we learned about the type conversions in the case of primitive data types. In the case of non-primitive data type, means in the case of classes also, this type conversion concept is there. Just like the data types, the objects can also be typecasted. In objects, there are only two types: parent object and child object. One type of object, that is child object or parent can be converted to another. That is the conversion what we are doing in the case of objects. So the conversion is between parent type to child type or child type to parent type. Upcasting is nothing but upcasting is the typecasting of a child object into a parent object. So this is the parent, this is the child. Upcasting means converting the child to parent, up. Downcasting means converting the parent to child. Okay, here you can see one example. Parent is the parent class, child is the child class. Parent p equal to new child. Upcasting. This will happen without any additional code. This works fine. This is allowed. For upcasting, you don't need to do anything. But if you see this, okay, I created a reference child c equal to new parent. This is downcasting. If I try to run this code, I will get error. For this, I have to do the explicit casting, means I have to do the downcasting. So upcasting will happen implicitly. For downcasting, I need to do the cast operator. Child c equal to, I need to convert this parent object to child object. So cast child, that is the data type. So I am doing the downcasting. So here it will perform the downcasting, but you have to handle one exception that you will learn when we study the exception handling. So that's all about for this lecture. Thank you for watching.